Welcome to SCARLET. SCARLET, which stands for Scalable and Reconfigurable Electronics Platforms and Tools, is an EC-funded FP7 first call project coordinated by Thales Avionics. This presentation will provide you with a general overview of the SCARLET project. It's therefore oriented towards a short context and market drivers analysis to end up with a description of the SCARLET overall objectives. I propose we first go back to the past time when the federated architecture was mainly used. The federated architecture is that kind of architecture where each function is implemented during a dedicated piece of hardware called LRU. The communication between the functions is supported through ad hoc interconnections. Consequently, the development of a function requires not only the development of a specific hardware, but also of a specific operating system. In the 80s and 90s, the growing number and complexity of the functions on board of an aircraft highlights the drawbacks of this type of architecture. The main drawbacks one can think of are the cost of spare part, the management of obsolescence, the maintenance cost, and last but not least, the complexity of functional upgrades. During the same period of time, in terms of new market drivers, the request for an increase in operational reliability, a reduction of the set of part numbers, so to reduce the number of spare parts to store, as well as a reduction of the cost of avionics parts through common hardware to several functions became strong airline requirements for a cheaper and more efficient aircraft. Changes needed to shift from a legacy approach to a new approach, capable of overcoming the federated architecture drawbacks and providing an answer to those market drivers requires expertise and agreement from several actors of the industry. The IMA-1G concept was born. Developed for the A380, existing on an A400M and Russian regional jet, but also on board of many other type of aircraft, the IMA-1G clearly overcomes the drawbacks of the federated architecture. Moreover, it provides new technological concepts, such as the AFDX backbone network, as well as a new way of working, like the incremental certification process. The IMA-1G fit for purpose brought many benefits, and was considered and shall still be considered as a huge success. Nevertheless, as in any industrial revolution, the trade-off made at that time between market needs, technology feasibility and industrial reality started showing some slight drawbacks, such as several different types of module were necessary, mainly because of co-location of I/O within the processing module. Typically 7 different types of CPIOM have been defined to host large AC functions. Consequently, software applications were tied to specific resources, still because of I/O's co-location, de facto limiting flexibility to address new customer needs. The sharing of hardware resources only applied for a selected number of applications, and the common toolset is somehow too much module-oriented. On the other hand, the incremental certification process shows no drawbacks and remains a competitive asset. When looking at today's context in terms of aircraft orders at entry into service, this first bar chart shows a very demanding ramp-up phase. This need for early maturity makes it not possible to reinvent new systems, and especially hardware or architecture for each aircraft program. Thus, increasing the set of function on board of the IMA is a way to allow to go one step further in the maturity of the IMA core electronics at entry into service, simply because more and more function suppliers will use it. This will also enable the function suppliers to only focus on their primary goal, the overall EIS maturity of their system. This second bar chart illustrates the growth in the number of functions to be hosted on board of the IMA. It clearly highlights that the future IMA platform will have On one hand, to host more computing power and enable more interfaces capabilities. On the other hand, not to increase weight, power consumption and volume of the future IMA solution. Today's additional market drivers. Let's first quickly recall the market drivers to which the IMA 1G managed to answer. At that time, the request for an increase in operational reliability as for a reduced set of part numbers so to minimize the spare parts to store, along with a strong request for reducing the cost of spare part through common hardware to several functions, became strong airline requirements for cheaper and more efficient AC. Not to forget the constant pressure for a reduction in terms of weight, volume and power consumption. Definitely the costs clearly became the main driver. So if we now look at today's market drivers, not only shall we cope with an increased pressure of those classical market drivers, but to remain competitive, one shall now address additional key market drivers. The interest of airlines is searching for newer solutions to reduce their operational costs, lead them to consider avoidance of unscheduled maintenance as a potential source of such cost reduction. Scalability to various aircraft types is now to be further enhanced, as it is not possible for designers to go for a tailored solution for each new AC. We'd rather go for a solution that would fit multiple aircraft needs to comply with the envisaged cost reduction of the development cycle. A new conceptual step change, which might be smaller than for the IMA-1G, but one never knows, needs that representative actors gather again their expertise to define a new architecture solution and go together for a further step. An IMA-2G answer to those new market drivers is needed. SCARLET intends to suggest and provide such answers through a set of dedicated top-level objectives. That's provide a scalable solution, define a minimal set of modules, increase the number of supported functions, propose and develop new standards to support IMA 2G concepts, provide enhanced process and toolsets, and demonstrate fault tolerance through reconfiguration. The ultimate purpose of SCARLET is then to define and demonstrate the basics of a given implementation of the IMA 2G, the Distributed Modular Electronics or DME. Thank you for listening. We hope this short introduction to the SCARLET project gave you a better understanding of the set of SCARLET research activities. Please visit our website, and should you have any further questions regarding this video presentation, please do not hesitate to contact any of the persons mentioned. Thank you for your attention.